now we are going to represent vectors in 3D, 3D dimensions. So vectors in 3D. It is the same exact idea, but instead of having 2 coordinates, we are going to have 3. So we're going to have 3 axes like this. This is the z-axis that's going to the ceiling. The one that's facing you is the y-axis. The one that is coming towards you, this is not 2D, this is going out. So this is the x-axis, okay? Exactly. So if I want to represent any vector here, the vector v will have 3 coordinates, x, y, and z. So let's say I want to represent vector v, which is 2, 3, and 4. The coordinates of, this is the x, this is the y, this is the z. So what is that? How can I do this? I go 2 units in the x direction. So I am here now. Then I will go 3 units in the y direction. So this is 1, 2, 3. So I will be here. This is like the floor level. This is the plane, the floor plane, x, y plane. So then I will go up 4 units. So let's say 1, 2, 3, 4. And I told you before, position vector always has the tail at the origin, 0, 0, and this will be the head of the position vector 2, 3, and 4. So the vector will look like this. But be careful, this is not 2D, this is up. This is in the air, okay? So I want to show you how the vector looks like. In 2D, the vector is here, like that. In 3D, it is like, this is the y-axis, this is the x-axis, this is the z-axis, and the vector looks like that. It is out in the air, okay? And the tail is at the origin, okay? So this is how we represent vector in 3 dimensions. Okay. Now we know that the unit vector. So let's say this is vector v. This is representing vector v. We know that the unit vector in the direction of v will be a vector that's in the same direction as vector v, that small vector. However, the magnitude of this vector is 1. And we said that unit vector v equal vector v divided by the magnitude of vector v. Alright? The unit vector u equal the magnitude of vector u divided by equal vector u divided by the magnitude of vector u. Okay? So the unit vector of v, we're going to write vector v. Vector v is represented by those 3 numbers. 2 in the x direction, 3, 4, because this is the head of the position vector v. So I will write 2, 3, and 4. Divided by the magnitude of the vector. The magnitude of the vector is, so the magnitude of vector v or any vector is square root of x squared plus y squared plus z squared. The 3 components here squared and added together, and we get the square root of this. So square root of 2 squared plus 3 squared plus 4 squared, which is 2, 3, 4 divided by square root of 2, 4, 9, 4, 9, and what? And 6. So 4, 39, 16, 9, 25, oh, 29, 16, 9, 25, and 40, 29, yes. So now we know that the unit vector v will have the components x, y, and z as 2 over square root of 29, 3 over square root of 29, and 4 over the square root of 29. This is the coordinates of the unit vector. This vector has a magnitude of 1, so if you square those and you add them like this and you get the square root, you will get 1 unit. It has the same, the magnitude is 1 and has the same direction as vector v. Okay, so this is the unit vector algebraically. So let me say if I want to find, so this is how we find the unit vector. Write the components of the vector divided by its magnitude. And here. Usually mathematicians don't like to have irrational numbers in the denominator, so we can multiply the top and the bottom by square root of 29. For me, I don't care that much. But it looks better if you multiply, so it should be 2 radical 29 over 29. But up to here, I am fine. Okay, now I want to go and further and tell you about special unit vectors. Special unit vectors. I, J, and K. What makes those special is the following. Again, we said that the one to the sky is Z, the one that's facing you is Y, the one that's coming towards you is X. I is the unit vector in the direction of x-axis, in the direction of X. So this is I. So who can tell me what's the coordinates of I? I go 1 unit in this direction and I didn't go anywhere in the y or the z direction. So the coordinates of unit vector I is 1, 0, 0. J is the unit vector in the direction of y. Unit vector in the direction of y. So this is J. What is the coordinates of J? It will be, I didn't go anywhere in the x direction, so 0. I did go 1 in the direction of y, so 1. And I didn't go anywhere up, so it is 0. And it is very clear that the unit vector in the direction of z is k. 1 unit in the direction of z, that's k. And the coordinates of this would be 0, 0, 1. Right? Okay. Now, those are special unit vectors, I in the direction of x, j in the direction of y, k in the direction of z. Now let us say the last example, vector v was 2, 3, and 4. So I went 2 in this direction, then I went 3 in this direction, 1, 2, 3, 1, 2, 3, so, and then I went 4 in this direction, so 1, 2, 3, 4, and this was the vector v. So this is vector v. Okay, remember this is in the air outside, so this is vector v. I can represent this in terms of I, j, and k as sum of I, j, and k. So I want to write this as sum of vector I, vector j, vector k. If you look at it, I can write this as a sum of these vectors. This one, the head here, in this one, then this one, right? This vector plus this vector plus this vector will equal vector v. This vector is 2 times vector I, so I can write vector v equals 2 times vector I plus 3 times vector j. This vector is 3 times vector j plus 4 times vector k. So any vector I can, in the world, I can write it as sum of those 3 unit vectors. Okay? And vice versa. If I have it as sum of 3 unit vectors, I can write it with coordinates x, y, and z like this. So for example, I want to represent vector u, which has coordinates of 3, 0, and 5, or negative 3, 0, and 5. I want to write this as sum of 3 vectors, I, j, and k. So I can write this as negative 3, I, plus 0, j, so 0, plus 5k. Okay? What if I have this vector as sum of those vectors? Negative 2 over 7j plus 12k, something like that. I want to write it as coordinates like this. Did I go anywhere in the direction of I? No. So 0. What is, I went in the direction of j to negative 2.7, so this is the y coordinates, then 12. And that's how we do it. Okay? I hope you have a great day. I will post this with the homework. Anyway, I can write the homework here. So homework, page 326, number 16 and 17, and page 337, number 10, 11, and 14. Okay? See you soon. Enjoy the rest of the day.